Hey everyone, and welcome. So if you've ever tried to learn data structures and algorithms, you've probably noticed that most guides either totally ignore the C++ STL, or they just dump theory on you like a boring old textbook. But here's the thing, in a real coding interview, the STL is your absolute survival kit. So today, that's what we're building. No theory, just the practical tools you actually need to solve problems and solve them fast. All right, let's kick things off by looking at the problem we're all trying to survive. We've all been there, right? You totally get the logic behind a data structure. You know how it works. But then the interview starts, that clock starts ticking, and you're staring down a pretty terrifying task. I mean, who in their right mind wants to spend precious minutes manually coding a linked list, or heaven forbid, a hash map completely from scratch? The pressure is on, and let's be honest, it's a perfect recipe for tiny bugs and just completely wasted time. There has to be a better way. There is a better way. And this, right here, this just says it all. On one side, you have the manual way. We're talking dozens and dozens of lines of code, it's slower, and your brain is focused on boilerplate, not the actual problem. And on the other side, the STL way. A couple of powerful lines, it's lightning fast, and all of your brain power is aimed directly at the core logic. It's a no-brainer. This is where your new best friend comes into play. The C++ Standard Template Library, or as we all know it, the STL. You gotta think of it as a pre-packed toolkit designed by absolute experts just to make your life easier. So what does that actually mean for you? It means all those complex things, dynamic arrays, stacks, hash maps, they're already built, they're already tested, and they're already optimized for you. You just need to know they exist and how to use them. And that brings us to the most important mindset shift. Coding interviews are a test of how you solve problems, not how well you can reinvent the wheel under pressure. The STL is what lets you focus on thinking smart, not on coding hard. So, what's actually in this survival kit of ours? Let's unpack the absolute essentials, the tools that will get you through, I'd say, 99% of any DSA problem you're going to face. First up, and you can probably guess this one, it's the vector. And honestly, this is the most important tool in the whole box. Forget about old-school fixed-size arrays. A vector is a smart array. It just grows automatically when you add stuff to it. It should be your default choice for pretty much any list of items. And look how easy it is to use. Pushback just adds a new element to the end, and you can grab any element using its index, just like a normal array. Simple, clean, effective. It's that easy. Okay, next up, we've got the stack. And the best analogy, the one everyone uses because it's perfect, is a stack of pleats. The very last plate you put on top is always the first one you take off. We call this last in, first out, or LIFO. And the code, it mirrors this perfectly. You push items onto the stack, and the top function lets you just peek at the last item you added. You can see we push 10, then 20, so 20's on top. Stacks are amazing for any problem involving reversing things or matching parentheses. Now, the opposite of a stack is a queue, and you can think of this one exactly like a line at a ticket counter. The first person to get in that line is the first person who gets served. This is first in, first out, or FIFO. And yeah, the code is just as simple. You push new elements to the back of the line, and you access the one at the front. Here, since one was pushed first, it's patiently waiting at the front of the queue. This is absolutely essential for algorithms like breadth first search. All right, let's talk about keeping things unique. What if you need a list of items where you just can't have any duplicates? Well, you've got two main choices. A set will store only unique items, and key feature, it keeps them automatically sorted for you. An unordered set also only stores unique items, but it's way, way faster because it doesn't care about order. So the trade-off is super simple. Do you need order, or do you need speed? Most of the time, you need speed. Now, what if you need to connect one piece of data to another? Like a student's name with their test score. That's what a map is for. It stores these key value pairs, and just like a set, it keeps everything neatly sorted by the key. But just like with sets, there's a faster, unordered version. And I really want you to pay attention here because the unordered map is, and I'm not exaggerating, probably the single most powerful and most frequently used tool in your entire DSA survival kit. Why? Because its speed for looking things up is, on average, constant time. It's crazy fast. And this, right here, this is its killer application. You need to count how many times each number appears in an array. Look at that. With an unordered map, it's a single, beautiful line of code inside a loop, freak x++. This one pattern solves a massive number of interview problems. It's like a magic trick. Okay, so we've got our core data structures. But wait, there's more. The STL also gives us a huge library of pre-built algorithms that work directly on these structures. These are your power moves. Need to sort a vector? That's one line. Sort. Need to reverse it? One line. Reverse. Want to find an element or count how many times it shows up? Again, a single, powerful command. Mastering these saves you from writing so many tedious, error-prone loops. It's a lifesaver. So we've unpacked the kit, we've looked at the power moves. It really all comes down to one simple guiding principle, a golden rule you should take into every single coding interview. Using the STL isn't just a tiny improvement. It's a 10-fold improvement in your focus and your efficiency. It lets you spend your precious time on the actual logic of the problem, not on the manual suffering of implementing everything from scratch. More logic, less suffering. And here is that golden rule, plain and simple. If a built-in STL feature can solve part of your problem in 5 lines when it would take you 50 lines to write it yourself, just use the STL. Your interviewer wants to see you solve the problem, not prove you can write a sorting algorithm from memory. So what's the ultimate takeaway here? I want you to think of it like this. Basic arrays are stones. They work, but they're primitive. The STL gives you a full set of power tools. And mastering DSA isn't about being the best stonecutter. It's about knowing which power tool to pick up to build a solution fast, clean, and with total confidence. Now go practice with these tools.